Now, as promised, I want to show you something real quick about multiple inputs to a function. Before I return to the PowerPoint, though, I just want to show you something here. We've actually talked about multiple inputs to a function before. We just didn't use that term. I mean, like, for example, here I have a very basic printf statement here where I have a printf, and then my string that is using for its format is one value %f, other value %f, and then there's two arguments, a and b, where both a and b I declared as floating point numbers. I just set some stupid values in there just for something to do. And then there are actually three arguments to the printf function. One is this string that controls what the output is going to look like. And then here's an argument that goes into the function. And here's the other argument that is input to the function. It's going to end up actually as this part of the printf statement. Now, we didn't talk about this in the context of passing values to functions and so on, but we certainly could have. And I mean, something like this works just fine if I compile it and run it. I mean, all it just says is one value is 10.1 and the other value is 12.2. But it gives you an example of what could be done with such a idea of having multiple inputs to your functions. But we're going to need this for lots of applications in our work. For example, when we compute things like vapor pressure, okay, we're going to need to have things like the pressure and the actually, I don't think we do for that. Potential temperature. Potential temperature will be one of our functions. It'll be it needs two inputs. It needs the temperature of the air and it needs the pressure of the air. In the same sort of way, here's a function I've created called area. That's just going to compute the area of a rectangle, but it's going to need two arguments. It's going to need to know how wide the rectangle is and how tall the rectangle is. I've happened to save space called those variables x and y. But here I made x equal to 10, y equal 15, and then I invoked a function that I called area, and it has two arguments, x and y, where x is the width and y is the height, and area, a, is just going to be width times height. So the first argument, x, gets passed into the first function, to the first, it's going to be the first variable. In this case, it's going to be width, which is declared to be a floating point number. And the second one, y, will get passed into height, which is declared to be a floating point number. And so I just created a floating point number called a, made a equal to width times height, and then returned a to the main program, which in this case is just going to print those values. Now, what you're going to do in your assignment is whatever it says. I didn't write the page number this time, but it's at the end of that chapter about functions. And it's going to be writing a set of functions that create calculations that creates these calculations: saturation, vapor pressure, relative humidity, mixing ratio, relative humidity, blah, 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 everything that it says there, okay? You're going to make a function that can do all these things, a set of functions that can do all these things. Now, I'm going to show you. Now, you need to make sure you use, you can prompt the user for things like temperature, dew point, wind pressure, wind direction, and so on, pressure. And then you're going to use these variables to work with the observations of the functions that you've been given. You have to be very careful about your units to get this to work. I'm going to be providing you with a working version of the program that I created so that you can test your program against mine so that you'll know if your answers are right. All right, let me go ahead and show you what this is going to look like. What we're going to do, though, is a little bit different than the way than the way I've showed it to you before. If I go back into that functions.c program, see how we put this acres to square meters function between main and the pound includes. That's a lovely place to put it, but here's the deal. Let's say I now work on another program and I want this function again. Okay, it's not the end of the world. I can just cut and paste this or whatever into my new program. But you know what's better? Let's go ahead and start making our own library of functions. Where just like math.h and stdio.h, let's build our own. And I'm going to tell you to call it metcalc, metcalc.c. And metcalc.c will be where we put functions that we want to use in all of our programs from now on. And it's just going to be our little tradition here. We're going to put them in there. Now, I actually have already created a function library called metcalc.c that's going to have all kinds of things that we're using, not just now, but other times in the semester. I'm actually several assignments ahead of you guys right now. And so there's some of these in here are not what you're going to be using. So to make this different, I'm going to call mine metcalc Oh, I don't know. How about capitals? That'll work. It's different. metcalc. But whatever, it doesn't really matter. But this is where I'm going to make my library. I'll even put a comment there. This is the library of functions that I will use for the rest of the semester. Okay? And we'll work on building this. So for example, let's say I was making a new program. I'll just call it test.c. And in my new program, pound include math.h, pound include stdio.h, main. All right, let's just say, let's make something very simple here. Let's say printf, enter a temperature in Fahrenheit. Something like that, fine. And we'll scan in %f format. We'll call it TF. Let's call it temperature F. Okay, and don't forget, we have to actually have that ampersand in front of it. That is part of how scanf works. We'll learn more later in the semester as to why there has to be an ampersand there. Let me go ahead and make a variable called temperature F and temperature C, because you can see where I'm going to go with this here. Heck, let's put some comments in here. Get the input from the user. All right, and then do the calculation using a function. Calculation using a function. So like I'll say, and I'm going to use cut and paste to make this work better. Temperature C equals, I'm going to call my function F to C of temperature F. And again, I'm just using cut and paste because I'm feeling lazy. All right. And then if I printf something like that, %f Fahrenheit is %f Celsius. You've seen this before, right? And we got to make sure then we have temperature Fahrenheit, comma, temperature Celsius. Lovely. This almost would work. But the problem is, let's go ahead and try. If I try to compile this, gcc test.c minus lm. Error. Missing, I missed a terminating quotation marks there. Let's go fix that error first. I missed the quotation marks on this very last line here. All right, we'll compile that again. Compile. I'll use bang G, my little shortcut there. In function main, undefined reference to F to C. It's because it doesn't know what F to C is. Well, that's because it's a function I haven't written yet, and I haven't told it where it is. So let me go back into my metcalc.c function here, library, and I'm going to create one. It's going to be a function called F to C, and it gets one input, which is a floating point number, which we'll call F. Okay, that is the temperature in Fahrenheit. Oh, I better put myself a little comment here. This function converts temps from F to C. Okay, that's close enough. It's not a great comment there, but whatever. We're going to need a floating point number in there, which I'll call C. C equals F minus 32 times the quantity 5/9. I think that's right, isn't it? Return C. So, some variable is going to get passed into the universe that is this. Oh, I made it void. What am I thinking? It's a float function. Float. It's going to return a floating point number. All right, and it's going to return a floating point number. It's given a floating point number F. F minus 32 times 5/9 is going to be equal to C, and then we return C. The whole thing is going to go back as C. Now, I've written that, all right, but that is in this library, metcalc.c. So what I can then do is go back into, I think I call that program test.c. Let's pound include it. Pound include. Now, you might think what we want to do, this is wrong, but you might think what we want to do is pound include metcalc.c. That almost works. The trouble is these angle brackets. The angle brackets mean, well, there's a folder on Chesapeake, which is where the libraries are kept. Angle brackets mean it's in that folder. I happen to admit I don't remember where that folder is. I don't really care. A better option then, in this case, is to literally just spell it out. /home. In my case, this is the student 315 account. slash metcalc.c, quotation marks. I'm literally just telling it where it is. Angle brackets mean it's in the standard library, standard folder that contains libraries. I have to admit I don't remember where that is. Instead, we're going to say this one is in /home/student315/metcalc. So it will include that code. Now let's try to compile and run that. GCC test.c minus lm compiles up just fine. Let's a.out, enter a temperature in Fahrenheit. Oh, I don't know, how about 50? 50 Fahrenheit is 10 Celsius. Look at that, how that works. And see this metcalc.c library? We'll be able to use this over and over and over again. We'll have programs all semester. I mean, when you get toward the end of the semester where we're making beautiful weather graphics based on current weather observations, those observations are going to come in Fahrenheit. But when you want to do calculations, you're going to need to do them in Celsius. You'll need functions like this. You're going to need lots of these. I mean, this one works just fine. You know what else you're going to need? You're going to need a function that does things like C to F, where there's times where maybe you need to convert something from Celsius to Fahrenheit. So for example, maybe I want a Celsius to Fahrenheit function that takes a floating point number, which we'll call C for lack of a better name. And I'll go ahead and say this function converts temps from C to F. Okay, so it's going to need a floating point number in here called F. F is equal to 9/5 times C plus 32. Return F. So now the value of F will go back to the main program, and I'm pretty sure that this will compile. But what would happen if it didn't? Let's go back. What if I made a mistake? Let's say instead of I return F, I made a mistake and I made it return little f like this. What would have happened? If I tried to compile this, it would say in file included from test.c. Let me see if I can highlight that line for you. In file included from test.c, metcalc.c, in function C to F, error. Little f undeclared, first use in this function. Return little f. We go back here and fix that line in metcalc.c back to a big F, and it'll compile just fine. Here, let me clear this out and compile it. There you go, compiled. What if I went back into my test.c program and I made a mistake? Let's just say I forgot this semicolon right here. Common mistake. If I tried to compile that again with bang G, in function main, expected ampersand, I'm sorry, not ampersand, semicolon before printf, that's on line 18. If we go back into there with VI, remember we can jump to the line where the error is. We learned that it was on line 18, so 18 capital G will take you to the line. It said it was an error, actually it was expecting the semicolon before the word printf, and that's correct, right? It's actually up here on line 16 that we need the semicolon. The error messages tell you what the error is. I know it can be difficult. I know it can be frustrating, but the error messages do let you know what they mean. Now, if I go back over here and I go back into my metcalc.c function library here, you're going to need a lot of functions here. This assignment requires you to write functions that do all kinds of things. Vapor pressure, mixing ratio, all kinds of temperature conversions, all kinds of wind speed conversions, etc. It's going to take a little while to get these all right. Just to give you a sense, if I go back and look at my little metcalc.c, which I've been building this semester, it seems I reinvent the wheel every semester. Okay, this decode pressure is something you'll use later in the semester. Decode wind is something you'll use later semester. Skip to end of line is another function you'll use later in the semester. But look, here I've got my F to C function. Here I've got C to F. Here I've got C to K. Here I've got a function called K to C for Kelvin to Celsius. Here I've got knots to meters per second. Something just fell over upstairs. I'll get that in just a minute. Okay. Vapor pressure. Somebody's shouting it's okay. Vapor pressure, because you need a function that can compute vapor pressure given temperature, which, by the way, is the same function. If you think about it, if you know the meteorology, if you're given a dew point, if the number that goes to the vapor pressure function is a dew point, you're going to get the vapor pressure. If the number given is a temperature, it's going to come back, it's going to be a saturation vapor pressure, or feel free to write two different equations. I don't really care. Relative humidity. This is educational. Let's take a look at this. Here I've made a function called float relative humidity. Okay? At some point, I'm going to be able to call a function called relative humidity. I'm going to give it a temperature in Fahrenheit and a dew point in Fahrenheit, and it's going to return the relative humidity. Well, if you go to that Common Meteorological Calculations appendix, you find out that relative humidity is equal to vapor pressure divided by saturation vapor pressure times 100, which means we actually first need to compute the vapor pressure, which is going to be using that vapor pressure function based on the dew point, and the saturation vapor pressure, but using that vapor pressure function based on the temperature. But that function requires a dew point and a temperature in Kelvin. So first we need to compute the temperature in Celsius from the temperature in Fahrenheit, and then convert that to Kelvin. See, I have a variable called temp C, which is F to C of temp F. And notice that we have a variable called temp K, which is C to K of temp C. Oh, isn't that smart? Look at this. We're using functions inside of other functions. Of course we can do that. Okay, now as always, let me take a look at the assignment 6.txt file I have here just to see if I have everything I've told you. They need to understand the scope of variables. That's what we did talk about. We talked about the fact that the functions are like independent little universes. Variables that are in the main function, you can't see them inside of the functions themselves. Inside the functions, the variables that were inside the functions, they are gone. When execution goes back to the main function, they are gone. You can't see them. There's a scope to those functions. Make sure they understand that functions can use other functions. That's just what we saw actually with that relative humidity one. Yep, you are going to be using a function library called metcalc.c, which will be just useful. Let's just go ahead and do that. And it says here that you need to make sure you make the reference to the library absolute. That means that it has to be that pound include quotation marks, home slash home slash whatever your account's name is slash metcalc.c. That way, one semester we tried to link them using what's called a relative reference, and it was a disaster. Let's not do that. You can nest function calls. We did talk about that. I understand what I provided them a model program should do. You should be getting the same answers. Yep, I'll send you an email message that tells you the name of the command to execute to get my version of the program. You won't be able to see the code, but you'll be able to see what the output looks like. And so when your output looks like that, you know you have the right answer. Okay, I think that's everything. Please let me know if you have any questions. This is a fun assignment, but it does take a while. You're going to have problems, and I'm going to have fun helping you decode it. Please let me know if you have any questions. This has been Dr. John Schrage.